Imagine being locked in a room with no sound, no hum of electronics, no distant traffic, no wind, nothing. How long before you start to panic? For most people, the answer is minutes, not hours. Minutes. In 2014, researchers at the University of Virginia gave participants a choice: sit alone in silence for 15 minutes, or give themselves an electric shock. 67% of men and 25% of women chose the shock. They preferred physical pain over quiet. This isn't weakness. This isn't a modern attention deficit. This is your brain working exactly as evolution designed it. Silence terrifies us because for hundreds of thousands of years, silence meant death was coming, and that ancient programming is still running in your head right now. Tonight, when you automatically reach for your phone to play a podcast before bed, when you feel the urge to turn on the TV just for background noise, when the quiet of an empty house makes your chest tight, that's not a character flaw. That's your ancestors screaming a warning from inside your DNA. The question is, why did our brains evolve to treat silence as a threat? And what is this ancient wiring doing to us now that we live in the safest, noisiest era in human history? Rewind 200,000 years. You're a Homo sapiens on the African savanna. No walls. No weapons worth mentioning. No fire if you're unlucky. What keeps you alive? Your ears. The savanna is never quiet. Insects buzz. Birds call. Small mammals rustle through grass. This is the sound of safety. The sound of normal. The sound of nothing trying to eat you right now. But when a predator approaches, everything goes silent. Insects stop. Birds flee. Prey animals freeze. This is called the acoustic startle response. And your ancestors who noticed it survived. The ones who didn't became dinner. So your brain evolved a simple rule. Sound equals safety. Silence equals threat. Pay attention when things get quiet. This wasn't subtle. This was burned into your neurology with the fire of natural selection. The humans who felt calm in silence got ambushed. The humans who felt anxious in silence stayed alert and lived to reproduce. Guess which type you descended from? But here's what makes this really interesting. Your brain didn't just learn to notice silence. It learned to fear silence before the danger even arrived. It learned to treat the absence of sound as the presence of threat. Now let's look inside your skull. Because what happens in your brain during silence is genuinely strange. You'd expect that when sounds stop, the auditory cortex would quiet down. Less input, less activity. Logical, right? Wrong. Neuroscientists at Johns Hopkins discovered something counterintuitive. When sounds suddenly stop, specific neurons in your auditory cortex actually increase their firing rate. Your brain doesn't just passively notice the absence of sound. It actively responds to it. There are neurons whose job is specifically to detect when things go quiet. They're called offset neurons, and they're essentially silence detectors. Alarm systems for when the acoustic environment suddenly changes. When these neurons fire, they trigger your amygdala. That's your brain's threat detection center. The part that generates fear and anxiety. The part that floods your body with cortisol and adrenaline. So silence isn't neutral to your brain. Silence is a signal, and that signal says something.